Hello, today I'm going to be talking about teaching 2-digit by 2-digit multiplication to 4th grade students. This is using an approach founded in constructivism, where students are going to be building upon their prior knowledge to create some new understandings. So whenever you're introducing this to 4th graders, you're going to be thinking about what do they already know. So they've probably seen 1-digit by 2-digit multiplication, as well as repeated addition. So if I wanted to multiply 15 by 11, I could use a strategy that I'm familiar with, repeated addition. In this strategy, I would simply add 15 11 times. Now, as you can see here, that's quite a bit of work, but I do get the right answer. I regrouped my 5s into 10s so that I made the addition a little bit easier on myself, less room for error. So although this strategy was very effective, it's not necessarily most efficient now that I'm adding bigger numbers many, many times. So what can we do that's similar to repeated addition? We could multiply. So today I'm going to teach you how to multiply 2-digit by 2-digit numbers using 3 different strategies. The first strategy is the distributive property of multiplication. The second strategy is the lattice method. And the third strategy is the traditional algorithm. The partial products method uses my basic multiplication facts that I already know to break down bigger numbers into parts that are easier for me to multiply. This is essentially using the distributive property here. So in this example, you can see how over in the corner I have 15 and 11, and I broke the 15 down into 10 plus 5 and the 11 into 10 plus 1. That's how we distribute numbers. The next step in this process is to create a table with a quadrant for each part. In my model on the screen there, I made it so that the 10s were bigger, the 1s were smaller, to kind of visualize that breakdown. You don't have to. It can just be a 4-square quadrant. You just need one box for each of the numbers that you're going to be multiplying. So since I broke the 15 into a 10 and a 5, I'm going to write 10 and 5 across the top, and the 11 into 10 and 1, I'll write 10 and 1 down across the side there. All right, so there's my 15 on top and my 11 down the side. The next step is just going to be to multiply, just like an array. So 10 times 10 is 100. 10 times 5 is 50. You can see how I multiplied that. And then I'm just going to move on down to the 10 and 1. 10 times 1 is 10, and then 5 times 1 is 5. The last step in this process is just to add up our numbers to get an answer. So in this problem, I would add 100 plus 50 plus 10 plus 5. And I would get 165 as the answer. Same thing as repeated addition. I only had to use my basic facts. And then addition at the end. Let's try a different strategy. So the next strategy I'm going to talk to you about is the lattice method. The lattice method's really nice because it only uses single-digit multiplication. And it also keeps the numbers very well organized. So the lattice is set up over on the side. You can see that it's the same sort of quadrant system that we used in partial products, but it's got some diagonal lines, and that's separating our place value. So the first step is to create a 4-quadrant lattice. So I'm just going to draw 4 boxes just like before. And now I'm going to separate those boxes with a diagonal line. Next, just like a multiplication array, I'm just going to put my numbers right on the sides there. So 15 on top and 11 along the side. This is my 15 and the 11. And so I'm going to start by multiplying 5 times 1. And we know that 5 times 1 is 5. But we've got 2 boxes here because the diagonal splits it. And that's to keep your tens and ones straight. So my tens are on the top. I'm going to write 0 tenths. And my ones are on the bottom. And it's 5 ones. And I'm going to do that again. 5 times 1, it's going to look exactly the same. 0 tens on the top, 5 ones at the bottom. Now 1 times 1, 0 tens, 1 1, and that's actually duplicate as well. All right. The next step is to add the numbers diagonally. So 5 is all by itself there in this diagonal, so I'm just going to put 5. In the next diagonal, we have 5 plus 1 to give us 6. The following diagonal is 0 plus 1 plus 0, which is 1. And the top is just a 0. So if I write my answer, it's 0,165. So that's one strategy. The most common strategy is going to be the traditional algorithm. The traditional algorithm is the standard method for multiplying large numbers. You'll write 15 times 11 vertically, and then you're going to start by multiplying your ones digit on the bottom by your ones digit on the top. So 1 times 5 is 5. You'll write the answer directly below the ones digit in the answer space at the bottom. Then you're going to multiply that the ones digit 1 to the tens digit 1, and 1 times 1 is 1. Now we've finished with our ones digit, so I'm going to cross that out so I remember not to use it again. And we're focusing now on tens. So the tens place also has a 1 in it. 1 times 5 is 5. And 1 times 1 is 1. If you want, you can put an X in your ones place there, just so you make sure that you don't accidentally slide your numbers over into the wrong place. I'm just going to add those up. 5 plus nothing is 5. 5 plus 1 is 6. 1 plus nothing is 1. And we get our answer of 165. Now you're going to try. Solve 17 times 12. Whenever you're doing this, I want to see that you're solving it using 2 different methods. You'll get 1 point for each way that you attempt. Make sure that you show your work. If you get the answer wrong, I need to be able to make sure I can see where you made your mistake. So you're going to get 1 point for having the correct answer and 1 point for demonstrating clear work. If you want an extra challenge, you can solve this next problem, 25 by 16, same rubric. And these example problems are going to allow for students to think beyond the metacognition portion of this lesson, and it's going to require that students are making connections to their prior learning, to their one-digit multiplication, in order to construct some realistic applications for regrouping within a problem and decomposing numbers with greater multiples than 10. I would then just allow students to share their different strategies with the class, and then we could come up with some good anchor charts for the walls. Okay. Thank you very much. Good luck. Bye-bye.